we are going to factor this right here. It is a perfect square trinomial method we want to try here. And what a perfect square trinomial method is talking about is if you have a square front part and a square back part, see for both of them, the answer could be these two pieces squared. There's two shortcuts. They're very similar. One just has a minus in the middle, one has a plus. So let's look. What we're trying to say here, all in all, is we're trying to see what squared is in front and what squared is in back. So the front part, what squared gives you 9x squared? That's 3x. What squared gives you 100? That's 10. I'm going to call this A and this B. C, A, B. Now, if this times this doubled matches the middle, I can apply my shortcut. If this times this doubled does not match the middle, I cannot apply these shortcuts. And I have to find another method or just assume it probably doesn't factor. So what I'm going to do next is I'm going to take this 2 times the 3x times the 10. And what do I get? 60x. Does that match the middle? Yes. Cha-ching. That means a shortcut applies. If this ended up being 80x, it doesn't match. I stop. I cannot apply a shortcut. Now, because it's not minus, I'm going to use the minus one. If this was a plus right here, I use the plus one. So, do we have something squared? Yes. Something squared? Yes. And do we have doubling the two pieces in the middle? Yes. So my answer is simply this minus this all squared. So my answer is 3x minus 10, A minus B squared. I'm done. Again, that's your A, that's your B. So a difference of squares. Here's your formula. If you have something squared minus something squared, your answer is going to be this piece plus this piece times this piece minus this piece. It's a real quick factoring technique if you have a difference of two square pieces. So let's check it out. For this problem, do you understand that's n squared minus 121, isn't that 11 squared? So that's your A, that's your B. Is that a difference of squares? Yeah. So my factored form is simply going to be n plus 11, n minus 11. Done. So for this one, let's do the same thing. Let's see if it's a difference of squares. So what squared gives you the first and what squared gives you the second? Hopefully you can see the first one is 7x times 7x, and the second one is 12 times 12. So that's your A, that's your B. Are they two squareds subtracted? Yes. So my answer is simply going to be A, which is 7x, plus B, which is 12, times A, which is 7x, minus B, which is 12. And we are done. That is my factored form.